next up we've got Chemouil. Close.
Somehow, yeah.
From Global Vision Systems, based in Toulouse, France. So Simon likes applying OSGi to, his OSGi expertise to Java, Eclipse, RCP, C++, and Android. So I guess that's why universal declarative services are of interest. He's also got an interest in functional programming and service and component-oriented programming, and how mixing those might help make software more robust and maintainable. So over to Simon.
Okay, just put the timer on. Okay, so welcome. And okay, so I named this talk Universal Declarative Services, and I will shortly explain the universal part. But it's a talk that has two parts. First part is about a component framework for C++ that's obviously based on declarative services, as in Java OSGi, and a model-driven solution to what I call polyglot components. I mean, they are in different languages, for instance, C++ in Java. So, just as Graham said, he said basically this line: I'm very lazy and I never want to write software again. So I tried to find ways to make it easy, and OSGi helps a lot with this. During daytime, the architect at Global Vision System in Toulouse. And what we do is data visualization software with 3D and 2D. So a large part of our middleware is in Java, but we have this 3D engine. This 3D middleware that it must be 3D engine agnostic. So we must plug into any kind of 3D engine. And that's basically a use case for services, components, and OSGi. So what am I going to talk about precisely today? The first part will be why we need that for C++, and why we need C++ maybe. Why that will service components make sense for C++. Then I will go a bit into details on how I implemented it, because obviously there are a few challenges. Then how we can make things work smoothly with Java and different languages. And I will conclude. Okay, so in case you missed yesterday's talk by Sasha, who is here, and Alexander, it was about native OSGi, and I'm gonna sum it up very shortly in 2 slides. So it all started with universal OSGi, which is a bit why I named this talk Universal Declarative Services. It's an RFP that was accepted, but there was no further work, and also it's the name of a blog post on the OSGi Alliance blog by Peter Krantz. So that was 5 years ago. And there have been some work, but in different parts. And now they are kind of coming back to the OSGi Alliance with a new RFP that has been discussed yesterday. So the general idea is to apply OSGi techniques to native development, because we find that this technique makes sense whatever the language or whatever the environment. So my story is that I have been working with OSGi in Java for a few years. I changed my job 6 months ago, and I came to this C++ engine that I was telling you about. It's a 3D platform. And it was already going through some kind of refactoring. And it had its own custom-made plugin system, the same kind of things we see in every Java, where every project has its own plugin system and no standardization on this. And it was very limited, like many Java plugin systems as well. That is, the plugins are services, they are components, they are plugins, there are no distinction, and they can't talk to each other. There can be only one layer of plugin, so if a plugin wants to have plugin, it has to define its own plugin system and so on. So I was thinking, this is a use case for OSGi. So I looked at C or C++ OSGi ports, and I found some. That was good news. I already knew about Celix. It was presented 2 years ago at the OSGi DevCon by Alexander. But this was C, and I wanted to do components. And components are very clumsy to write in C. You need classes, I think, to have something that looks like components at least. And Sasha talked in detail about all these frameworks, but the main thing is that there is CTK written by Sasha, and just a few months ago, just before I started actually, he took part of it, isolated just the core without dependencies, and he called that CPP microservices. It's a bit in the same spirit as Pojo SR. Let's just take our OSGi Connect. Let's just take a service registry, make it very light, no dependencies, and provide a very light OSGi framework. So for prototyping, it looked to me like the perfect solution. But even if there was all of these OSGi framework parts, and those are OSGi containers, and a few compendium services, there was no service component service such as declarative service available. And I was kind of surprised because when I'm doing OSGi, I want to have a component framework. That was in Emily's best practices. You don't do services directly, you use a component framework. So let's see, why should we need a component framework? A bit more details. That services are actually powerful primitives, yet they are very difficult to maintain. A service is basically an object that you publish into some kind of large map with listeners on that map, which is a service registry. And if you don't know how and when you should use it, you can very easily start doing messy things. And so you don't have a nice structure of how or when you should publish it. And these services are dynamic, so somehow you have to track when they go, when they come. And also, when you implement a service, you often depend on other services, so you have to track all these dependencies, and it very soon becomes difficult. And it also makes you depend on the framework API, because you have to depend on those listeners, and you want code to be modular and not have dependencies on this. So there is a very nice solution. These are the service components. They provide this structure by being able to say, I require these services, I provide these services, so you have a nice framework to think about. And the semantic model can help you reason about dynamism by just hiding you and shielding you away from it if you want. If you use, I guess, most of you know at least a bit about declarative services. You can have these static dependencies, which basically mean I want this service to be always available during my life cycle, and I don't want to think about thread safety or dynamism. I want just to program easily. So it provides a nice programming model. And so the question was, if it's so nice, why was there no such framework for OSGi for C++ yet? And okay, there are some technical challenges, obviously, but the main reason is that it was just not done yet. No one, there is not enough gain, not enough community behind OSGi C++ yet, so no one had really published one, at least. So why declarative services and not any other component framework for C++? Because there is a callback component model or a lot of component decom for Windows. I don't know, there are many, but there's exactly the same reason as for Java. There were lots of component frameworks for Java before declarative services, and somehow they didn't get things right because they had not the same kind of modularity. Because declarative service use OSGi and its service framework, it only does the component configuration, and so it's a very, very lightweight layer that can extend your bundles. And obviously, I knew it pretty well, and I think it's a simple yet mature and rich component models. It means that you can do a lot with little. And this is very nice because my C++ developers didn't know about declarative services. So I wanted them to get very quickly to being productive with it. And since the model is easy to reason about, it's very nice to introduce. And last but not least, it works with, so in Java, POJOs, plain old Java objects, are the equivalent in C++. It means that my components don't need to have a dependency on the framework, so I can test them easily in unit tests, or I can just change the framework, or even ditch the framework and wire them manually if it goes wrong, you know? So still, did it make sense for C++? And that was one thing I had to convince the C++ developers in my team, because C++ developers are even harder to convince than Java developers to change their habits, because they want to be very low level and control everything, and I have static linking everywhere. So one of the concerns was performance, because we do use C++ for performance and control of what happens in the hardware. And so the question was, is there a real performance hit with a component framework? Well, there is a time when the component framework has to wire all these components. But it doesn't happen much. It happens when you install a bundle or when you remove a bundle. But you're not doing that often, especially not in our environment. So once things are wired, these are just pointers. So you don't have the same compiler optimizations as with static linking, where it can just cross the boundaries of components. But still, you have pointers, and this is still very efficient. I was telling them, but do you agree that we do need extensibility and customization? Because we had this plugging system anyway. And they say yes. So shouldn't we do that in a modular way to make it maintainable and just allow to have not one plugin that does everything, but a bunch of components, and slowly, little by little, that got them to acknowledge that this is meaningful and it helps. So the last question that, from my point of view as the architect of both the Java and the C++ projects, is why should I use different architectural style? I mean, we have our Java and C++ is that far apart that we should use very different design techniques, especially when I have a design technique that works really well with Java. And I think, no, it's very, well, C++ obviously does a lot more than Java, and Java does a lot more than C++ in different directions. But they do have a common set of concepts, classes, inheritance, or implementation. And for me, it would be very, very practical to think only about components and not think like, is this Java and I have to go to the Java mindset, and I'm doing C++ and now I'm changing to C++ techniques for architecture. So I said, let's make a proof of concept, basically. So what are the challenges in C++? So when I started my proof of concept, I started looking for a native OSGi implementation. So I made a small tool. And as I said earlier, I used CPP microservices because it's light and it works with any shared libraries. So we already had shared libraries. I just want to load them dynamically. And somehow, and I won't go into details about this, but CPP microservices does the magic. It calls the activator when you load, and it calls the stop method when you unload the library. So I could declare my services this way. And I wanted C++, as I said, because I want concepts that map closely to declarative services. So I need classes, basically, and I need interface implementation. So we have virtual classes in C++ with pure virtual methods that can emulate Java interfaces. The only difference, basically, in CPP microservices, if you compare it to the OSGi core API, is that bundles are called modules to make sense with C developers. And these are not jar files or zip files yet, because this is a proposal with native OSGi. These are just native child libraries, whatever your OS is. And finally, the question was, this is a moving ground. I mean, maybe CPP microservices won't be long or maintained for long. Our product must be maintained for long. What happened then? And what happens if native OSGi gains traction and there are new standard implementations? Obviously, I want to benefit from this. Well, there is no problem because my components are framework agnostic. As I said, they don't depend on the framework. So only the component framework itself knows about the underlying implementation. So I could just rewrite that small framework because it's not that large and keep all my components running. And so all the code that has been made with my components will be able to move forward the day we have native OSGi. Or even if we didn't have OSGi, of course we will stay with it, but even if it had failed, we would have a way to wire them and still use them, because this is real modularity. You don't impose any kind of framework. So what do we need to do declarative services? What are the ingredients? So in Java declarative services, the components are described with XML files that live in the OSGi INF folder, usually. And when service come and go, there are service callbacks that are called in your POJO, like add service or remove service, and with this actual Java reference for that service. You can also say what kind of life cycle you want for this service. Do you want to have many of them, a collection, or you want just one of them? So that's the cardinality. You can say the policy. That means I want them static. It means that it won't change during the lifetime of a given component instance. Or dynamic, it can change, so I have to care about thread safety, for instance, but I can react to changes in the framework. And finally, target, to filter specific service based on their properties. And there are component callbacks, because sometimes you want to know when your component is activated, deactivated, and when its configuration changes. So most components actually don't need those, but the leaf components, those that are going to start a computation or anything, need to somehow start a thread or something. They need to know when they start and kill things, die nicely, as I heard in a previous presentation. So they need to know when they are deactivated. So let's see how I would define components in my declarative services for C++. So we had XML descriptions, but since we don't have JARs, I didn't really felt like putting XML directly in my native library and having this kind of large string as a static variable. So instead, I just defined a very simple descriptor type. So it's just once again, a data type, like a POJO or whatever. That is called component descriptor. It contains the same information as an XML descriptor for DS. And you register it to a component manager service, who is provided by the core DS for CPP framework. So this is the core system on how you should, I can describe it. So this is the class. So it has a component ID, which is the same as in declarative service. And the shared object is like the providing class, the implementation class, but obviously it's a shared object. And you have a number of provided services that are expressed as strings. And you have this complex type as well, component reference, which are like service references in declarative services. So you can say the name of the service you're interested in, the target, or how many of them you want. And then you can say if you want, okay, I kept this because it is in declarative services, but I don't use it. It's for further optimization to know if you want to have lazy component loading, and so on. So let's see what it is. So I will go through this example because I will keep it for the demo later and for the whole presentation. So just take the time. Okay. So we have two services in our example. I'm very, very original. I use a hello world, but I hope you can imagine it's a more complex system. So here we have a greeting manager service, which provides a facade to get hello worlds in different languages, or the word in different languages. For instance, if I'm German, in German I want Welt. If I'm French, I want the monde, and so on. And here I have a component providing this service, and it requires grid provider, which are basically providers for different languages. So this is the whiteboard pattern that is very common in OSGi. I say I want 0 to n of these services, and I want them dynamic. So they can come and go, and you can imagine like, well, I'm sure you know whiteboard. And here I have this console greeter. Basically, it's a console output that says, I need this grid manager service, and I need it statically. And whenever it comes, I will display all the hellos I have and that are provided here. So we will focus for the example right now on the grid manager imp component. So it's the most interesting because it both provides a service and it requires another service. So obviously it could require more, but this will be enough for the example. So this is not really nice to read, and that will be one of the main points of this presentation. But this is how I write the descriptor for that component manager imp. I say here, I don't know if everyone can see, but I say, these are my references. Look what the first reference, I only have one. It says, I want a grid provider, and that's the name of my service. And I want it to be dynamic. I want the references to be multiple and optional, so that's 0, n. And I don't have a target, so I say any service will be fine. I don't want to have a filter on these services. Here I say, here are the services that I provide. I provide grid manager. So these are C++ namespaces, as you see. This is like the package name, and this is the service name. And I imagine that we can just replace this by a single dot. If you come from Java, it's the same. And then I create the descriptor, and I somehow get my component manager service, and I register it, and I say from where it comes. Okay. So let's look at the implementation of that grid manager imp component. That's here. Okay. So now you should be really familiar with this, because this is very close, if not exactly the same, as declarative services POJOs in Java. You have the name of the class. You have the interface to implement. This is purely virtual. There are no methods defined here, except maybe an empty destructor. And so you have the component callbacks here. This is service callback for the whiteboard pattern. When I say, tell me when there is a new grid provider service, or tell me when one leaves. And here I declare all the service methods that have to be implemented from the grid manager service. So the method, just going through them, the default target is what I said. It takes a language, and it says, depending on the language, what is world, or so on, world, mondi in Italian, or whatever. Greeting is, say, it takes a language and a target. So you can say, hello, you. I can get all the greetings with the default target, so hello world, hello Welt, and so on. And then I can get all available languages that are defined here. There could be other ways, but this is a facade. It makes things easy for clients. So I hope you all see that this is as close as it can be from Java, and this really allows a C++ programmer to do exactly, very, very closely, like 90%, like a Java developer does with DS. And since we all know that DS works pretty well, it's going to work pretty well in C++. So how are these callbacks actually found, discovered, and called? Because in C++, there is no reflection or no introspection. And even if there are some libraries for this, actually, there is one called Reflex that's quite nice, but it's static. It finds all the symbols and puts them in your object. And it's not really what we want, and it makes the shared object a lot larger. So, and it doesn't work with recent C++ versions either. Then there is the main problem. We have this C++ name mangling. So in C++, when you define a symbol in your class, like a function or whatever, you can't know what will be the end name in the shared object because it's not specified. Every compiler and even the different versions of the same compiler will sometimes output different names. So this is because of function overloading. You have like different function with the same name but different parameters. So somehow they put the parameter name in the symbol name, and so you can't guess it. We can try. You could try, but it would not be scalable. Every time there is a new compiler, it won't work. So instead, there are two parts of the solution. First, I force a convention in my components. I say, if this is a single dependency, we will use set, the name of the service reference. So set grid provider, unset grid provider, or add grid provider, remove grid provider if it's multiple dependency. I use the same conventions for my bind and unbind methods in Java, so I really don't care. I guess we could make this configurable if you are interested. So the basic tools we have in hand to solve this are the primitive OS primitives for loading, dynamically loading and finding symbols. So dlopen, dlsim, and dlclose. They are the Windows equivalent as well. And to fight against name mangling, we have still to find what this is gonna be named in the shared file, shared object. So what are the solutions at our disposal? First, as I said, the reflection libraries. Not dynamic, and very limited because they don't support C++11. They only work with GCC or G++, and so on. Then maybe, I don't know, C++11 introduced attributes which are very similar to Java annotations, but they are still largely unsupported by most compilers. If you're interested in C++11, there is a compatibility matrix for every compiler over at Apache. Just Google it. And so this was not a solution. Then the last solution that seemed very good was Qt meta objects. It's actually special information that is added by the Qt framework that is very much used in graphical and in many C++ projects. It's quite nice, but it does need a custom preprocessor to register all the objects and put them in the library. And when I looked at it, it was going through a refactoring for Qt 5. It was still not very modular. They were trying to split the project and so on. So I wanted something, well, with fewer dependency. And what I did is simply to write C wrappers. So C++ has this ability to have extern C blocks where you don't have that name mangling and where you can still call the C++ code. So you could define your own mangling scheme. That is, okay, not really nice to write manually, and I'm going to show why in a second. But the advantage is that you also, with that, provide a universal application binary interface. What I mean here is that many languages from Python to Objective-Camel to whatever, basically, have a foreign function interface that can tap in C libraries very, very easily. And when I have my components with a very easy to look up symbols, I could use these components not only from my framework, but also from different languages. So this has like another advantage. So the problem you're gonna see right now is that it looks like this. So what I have done here, you don't have to actually see every line, but I have to define a constructor because you can't create a C++ object from C, so I have this create method. I have my own scheme of mangling when I say the namespace __ the class __ create, and I have these special methods for the component callbacks creator destructor. So create, activate, destroy. And I also have my add grid demo provider, and so on. Okay, that is not nice to read. And that is a problem, surely. But it works. So at that point, my proof of concept was successful, and my problem was that I don't want the developers to write these wrappers, and I don't want them to write the descriptors that we saw earlier, because they are not very nice to write either. And I want the developers to focus on business code and not on writing technical wiring glue code. So with that, I managed to have the DS component framework work with dynamically wired components. As you saw, I used the whiteboard pattern. The pattern worked nicely, so you can have the same kind of design style as in OSGi. And it's all dynamic and multi-module, so you can have different module providing components and everything works together. And okay, I didn't implement the full DS spec. I didn't implement component factories, but we are going to make them soon. I didn't actually implement component removal because we didn't need it, but because we just load and then we close the application. That's something that actually is kind of specified but still empty. And because we didn't have a multi-thread C process, because this is 3D and multi-threading in 3D is often discouraged, and we use the same thread to load everything, it is planned, and the code is, well, I made it to add thread safety later, but I didn't yet. But we do support whatever we did need internally. Yet, no one would write that, and I wouldn't want to use this. So before going to the second part, I'm going to go through a small, quick demo of how, oh no, I wanted to do that. Switch to Eclipse. So I have my project here. I made a demo. That is the one we described earlier. So as you can see, we have the different components. Grid manager, so we can see that's what I showed you earlier. We have the implementation, which obviously in C++ is not in the same file as in the headers. So this is basic, the same implementation as you would do in Java, and the wrapper code. That is not very nice to read. Okay. We have the module, which is the entry point with the activator, and the activator here you can see will define this service component provider, and this will be used this service will be retrieved by the system, and all these components will be wired and declared when they are satisfied, when the lifecycle is okay. And we have the two services here, so just to show you a bit how they look like. Okay. So I'm going to run the demo. And this is nothing fancy, of course. Oops. So you can see that we have several modules. And my launcher simply loads this module by name. Then the console greeter, I wanted to put Eclipse on here, but OK. The console greeter, when it activates, actually calls the component, the grid manager component or service to display these hellos. And after that, in my launcher, I show you that we have several modules that are loaded. These are like bundles. So I loaded the CPP microservices. This is a system bundle. We have this launcher. We have the declarative services for C++. This bridge is the thing that helps me bridge the services provided by modules to the system with using whiteboard, so I don't have to get the service. I can just publish a service. Okay, this you can talk to me if you're interested in. And this is the demo component. And then you can see also the services that have been registered in the framework. So I have some system services, and then 2 grid providers and 1 grid manager. Okay, so you see that the demo component, because it didn't provide any service, it was an immediate component, leaf component, so it's not here. So let's go back to presentation. So now I want to show you what I call universal declarative services, why you use this name, because it's not only native, it's about bridging different languages, and how I can solve this problem with wrappers and with component descriptions. So basically, it all boils down to C++ being too complex, its grammar very, very difficult to parse. So how could I get this component description? In Java, I really like for DS to use annotations, but there is no annotation processor for C++. Actually, there is, but like most C++ projects, it works kinda not. And there could be, I tried to use macros at first, and I managed to do something, but it was so ugly, I didn't even keep it in my Git history, I just threw it away. Then, parsing C++, I don't know, using Antler or something, and there are free grammars, but they don't support all of C++. I mean, even C++ compilers rarely support all of C++. So this was a no-no. The approach I took was the opposite. And I don't know if you know about the Xtext Eclipse project. It helps you define domain-specific languages very, very quickly. It's very easy. It's Java, so I can program it. And for free, you have an Eclipse editor, which is just nice to have. And okay, I don't like EMF that much, but a lot can be built upon it. I mean, like a graphical editor or whatever, because you have this EMF modeling model, kind of. So let's look at what my component looks like now when I use my small architecture description language. So this is exactly the information that we have in a declarative service XML file, but with syntax checking, semantics, and verification here. So I say that I have a component, that's his name. It provides this service, and it references in a dynamic way the service called grid provider with this cardinality, 0n. So I kind of find this really easy to read. And the idea here is that it will make my life easier, not only for C++, but maybe also for Java, because annotations are very nice for declarative services, but you can have a quite large component, and the bind methods can be pretty much anywhere in your component. And it's really nice to have a very quick view of what this component actually does, needs, provides, and this is it. Obviously, a bundle or a module does provide several components. So this is how I describe a module. I say, this is my name. I have like the symbolic name, because this is also a level higher of the bundle, like model-driven bundle. Obviously, I want a version. And I say the components that I want to include. It's called includes because I also can use wildcards or make excludes or whatever. So this, once I have it, I run my compiler that translates this very simple definition into the proper files. So this is the layout of a DS for CPP project, and it can be changed the day we have native OSGi or whatever. So I have the services. This is my shared services that I might provide to other components. So these are headers. I have the model where this file lives, so I can very easily and quickly go to the original specification of my components. And this is very nice also for documentation purposes. And finally, it generates my components with the headers, the source, the skeleton of my component that can be edited, and the wrappers in another folder, so I know I will always rewrite it. There is no need to just rewrite parts of the code. And the last thing it generates is those descriptors and those component provider services, because that was another part that I didn't want my developers to write. So this makes pretty much everything easy. So I think at this point I show you again, and I write a new component in like 1 minute if everything goes well. So I go to I'm still in the grid demo. I go to my module, and you can see all the components here. I have fancy things like this. I can see French grid provider, and I can click also here and see the service interface it provides, and I go to the C++ editor. So this is quite nice. The tooling is nice, of course. I customized it. It doesn't do that out of the box. And if I want to do a new component, I will do a German greeting, because we are in Germany. Okay, this is it. So I start saying it's a component, and I have code completion. I want to provide a service called grid demo that grid provider. I think it's basically the same as in French. It is. Okay, here I'm all done, but I have to add it to my module. I will add it here, and for fun, I also should have completion. Yes. So everything seems okay. I want to get this right from the first time. Okay. I just click generate here. I have an offline compiler as well for continuous integration. And if I refresh, no, I don't have to refresh. It's already refreshed here. And you can see that I have my wrappers already done. Okay, this is a fake error. CDT is not. That C is very hard. C++ is very hard to pass. So I have my interface here, and I didn't add the methods from the service interface, because somehow I would have either to pass the C++ interfaces, or I would have to add to my language an IDL to describe these interfaces. And this was a lot of work, so I'd rather just copy-paste what I have here, because it's the same. I just take these methods, I put them here in my header. Yes. I go to the implementation, and I don't want to do anything when I activate, actually. And I have just these 3 methods to implement. So I will go copy the French. It will be much easier. Okay, so I go here. I add the methods. The default target in German will be Welt. The hello will be Hallo. And the name, the language is dir, and of course I have to change this. Actually, CDT, the tooling is able to find lacking implement methods, but for some reason it doesn't work all the time, and I know that it won't work for this demo. So is everything all right? I think it is. So I should just be able to go to my build, just make, let it work. So you see that the module itself has been rebuilt because there is a new description in it. So the descriptor has been added. and you have these providers here that have been built. I go to bin, I launch it, and what is happening? Okay, there is a problem. I don't know, it's I'm under VirtualBox and it's playing with me. Okay, this didn't work. Okay, this is, I'm pretty sure it worked before. So okay, you see that the German greeting was not built here. I know what happened. I have to copy the CMake that adds to the build. And okay, that was not really nice. Yes. I hope it works this time, or else I will give up on this. Okay, you see that German has been built. Okay, we have the Hello here and the Hello Welt. And we see that there are 3 grid providers now, services available in the system. So basically, I generated a lot of technical wiring code, and it was quite easy for C++. I can tell you, because usually when you don't have this, it takes a lot of more time. So just a few minutes to say what's next. So what are the limitations? Today, this architecture description language, it only maps to what Declarative Services does. There are richer component model. For instance, at work, actually for Java, we use IPOJO, which is like Declarative Services on steroids. Obviously, it's fully OSGi, but it does a lot more as well. So it would be nice to create new backends for this ADL to write Java for DS, Java for IPOJO, and make it extensible to, I don't know, specific Android stuff, because DS and IPOJO work on Android, but there are some limitations sometimes. So whatever the language you have, if you can express components in Groovy or whatever, or Scala. Then there is the matter of bridging Java and C++, as I said. But this is not a component problem, because we are, again, in the modular world. And the services are meant in the native OSGi project to be bridged at the service layer. So this is under, and we can use the services transparently. So obviously, we will have somehow to expose Java interfaces for our C++ services to have static typing. And even if we could use network for the remote services, I think for performance, we can also have a GNI or GNA implementation, because for our use case, we don't want network latency, even if it's a local loopback, it's not as efficient as shared memory in the same process. So basically what we do is bridge 2 service registries. It does sound like CORBA, but it's the other approach. Instead of taking all the world and imposing it on you, you take small pieces, small parts, again, modularity, and at the end, you have the same outcome. But I think in a much lightweight and nice approach when you just take what you need. That changes everything. Then there is, we would like to create UI tools for diagrams, because these textual DSLs are nice, but I want to have a clear view, not component by component, but how they all interact together. And even I would like to have a static view of what I think is going to happen in the system, and maybe plug it to my framework to see what's going on dynamically, you know? This has been done, I mean, for other component frameworks, and even for OSGi. But it would be nice to have through Java and C++. So I think that going to model-driven engineering and go higher than just components with these kinds of descriptors is extremely useful, not only because it allows you to, it forces you to think about the model and the actual specification and not about the code, and speak a lot to your developers back and forth. But it also gives very good documentation, and no one likes to write documentation. We are writing an SDK. We are writing a platform. I want to have a service directory. I want to have diagrams. I want to have a clear map. And if I'm gonna do the diagrams at the end, after everything is done, it's not going to be good. It's not going to be up to date. I won't update it every time there is a change in the system. So if I make this the primary artifact, I'm guaranteed actually that this is going to be the real update thing. And we can also do static analysis, like to avoid cycles in my components, because cyclic dependencies are static. Cyclic dependencies are not good and even forbidden in DS. So this is more like a long-term project that we are kind of starting. So just to conclude, we have been using it for a few months. It does work. If you want to use it, we open sourced it. It's on GitHub. It's Apache license, so play with it. The demo is with it, so you can also start from this. And I hadn't actually programmed in C++ for like 6 years. It was very painful, and I'm glad now I don't have to do much of it. I can think about components. But if you know about C++ and feel like fixing things, sending pull requests, and just remove all my mess, feel free to do it. And I will be glad. Just talk to me after. About the tooling, it still have rough edges. It's not mature. So we are not open sourcing it now. Maybe I will try to convince, obviously, my company to do it. I don't feel like this is something I need internally. And what I've told you about these graphical, these interfaces, diagram components, deployment components, and so on, we have a real roadmap internally because actually I managed to convince my managers that this is going to be really useful, even if it's only it's not our business, but it's gonna be worth it in the long term, or even medium, short term. So this is it. I think I'm just in time. So please, if you have any questions.
Just not really a question, but so very nice. Obviously, it's great, and I like the idea of kind of using this new DSL for describing both Java and C++, modules that should work in either language. It's just, I used EMF like years ago, and at the time, so Xtext is based on EMF, right? At the time, you could get pretty far with generating, graphical editors based on EMF models. So that might get you to a certain stage where you can visualize.
Yeah, that would be actually pretty easy. Also, because when you serialize an Xtext model, it does serialize not to XMI, but to the actual language. So this is back and forth. But the Xtext EMF model is mapped from a kind of BNF grammar. It's not BNF, but it looks like it. And it's not exactly what I would use if I would make it my model. So there would be a model transformation and synchronization. And then the intermediate model would be the real UI model where I would plug a Jeff or some. Actually, I used to be an Eclipse developer as well. So I know I have some plans. I would also like not to use EMF, obviously, because it has singletons and everything we hate in Java, in OSGi, sorry. But it helps us getting things done very quickly. True. Any other question?
I have one more question.
Thanks.
It's been 10 years since I did some C++ work, but do you have some sort of an idea? I guess C++ is about two things. It's about speed, but it's also about footprint. Like the footprint is very small generally with C++. Do you have an idea how small this can go? Or?
This is very, very small. Actually, the component, the OSGi implementation, CPP microservice, that Sasha just here made, when you build it in minimum release size, it's like, I don't know, 40 kilobytes. And my thing is much smaller, much smaller. It's like nothing, It's another world.
Thank you, Simon.
Thank you.